Welcome, and in this tutorial, we're gonna see how to deploy a Python Django web application to Google Kubernetes Engine. Before we begin, if you would like to understand what is Kubernetes and its background, please do check out the Data Cloudies blog given at the description. Alright, as part of Prerequisites, enable the Cloud Admin, Compute Engine APIs, and then connect to a project. As you could see, I have downloaded the Python source code from the GCP GitHub. Okay, let us create the Cloud SQL-based PostgreSQL database. Provide the instance ID as polls for this example. Leave other options as default. This might take a couple minutes to spin a new instance. Meanwhile, let us go ahead and create a service account for interacting with the Cloud SQL to the front-end layer in the proxy, which requires a service account with editor privileges for your Cloud SQL instance. Give the name as polled. Assign the role as Cloud SQL with access admin privilege at this time. Generate the key in JSON format, which will be assigned to the proxy credential in the Kubernetes later in this tutorial. Alright, our database instance is ready now. Now, let's go ahead create a database on top of this instance. Name it as polls. And then, create a database user, name it as polls for this too. Let's head over to the Cloud Shell. Let me get the connection name from created DB instance. Missed S for instance. Okay. And then, we will pass the connection name to the Cloud SQL proxy. This has been downloaded before we started. Please follow the link given at the description to get this to be done. As we are going to test this locally first, going to create the proxy connection now. On the other hand, connect to another session and run the Python main script to create the Django models. Before this, set the local environment variables for database user and password which requires to authenticate the Cloud SQL connection. Alright, go ahead create the migration models such as make migration polls, migrate. And then, Run python manage.py run server. Perfect, now browse the localhost URL and verify the output. Excellent, it is working fine. Let us move on to the Kubernetes Engine configurations. There is some portion of the application code that behaves the static content. Since we execute the other parts using a unicorn environment as a dynamic model, these static contents need to be placed in the storage engine. So, let me create a bucket and assign the public to read permission. And then, generate the static content from the Python module and then, transfer the files to the created bucket. Now, open the settings.py file and replace the bucket name to the static parameter value. Now, go to Kubernetes console and create a cluster. Select the zonal location, and then, keep other settings as default. And, here is the equivalent command for the cluster creation, where we have assigned 2 nodes for this cluster. Go ahead, hit the Create button. Let us wait for a couple of minutes to get his availability. Alright, it is available after 2 minutes. Now, we will change the image name of the container, as we are going to build the same image in a few minutes. Now, get the connection name of a DB instance and then, assign it to the Cloud SQL connection string. Alright, save, and exit. Now, Get the credential to establish the authentication to the Kubernetes cluster from the Cloud Shell. This will create a connection establishment. And then, create the two secret parameter components. One is for Cloud SQL OAuth token, which we have taken from the service account. And another one is for connecting the Cloud SQL proxy user and password. Alright, now pull the Cloud SQL image from the GCE repository, which will be referred when we create an application image. The next step is, build the image with the exact as we have given in the polls.yaml file. Once complete, configure the default authentication and then, push the local image to the container registry as shown below. Verify the pushed image from the console. Now at the end, deploy the application to the Kubernetes cluster using the YAML file. Wait for a couple of seconds to get all the pods in running state. Check the kube service and get the external IP address to verify the output. We could see the polls index, as I did not integrate the static content with the previous module, we did not get the UI interface. However, we have the poll index module deployed in the kube cluster and all the pods are up and running. Well, that is it, we come to the end. Please do check out the procedure document at the below link and move on to the next topic. Thank you.